Hello everyone, last video before AMC, and we're just looking at a singular intermediate algebra problem today. And it's the AHSME 1961-29. So yeah, you have this polynomial and it has root s and r. Now we're trying to find the equation with root ar plus b and as plus b. So you can pause the video first and try it yourself. I would say one of the solutions to this problem is quite easy and you all should know it, but the other one is a little bit, at least I didn't know it. So first of all, this is definitely solvable with some common knowledge of Vieta's formula, which should I even go over that? Yeah, I'll go over some Vieta's formula. Let's see, let me get, okay. Here's our scratch paper with VS Code. So we have A, so A is the leading coefficient, x squared plus bx plus c equals 0, and the roots are s and r. And we're trying to find AR plus b as root and AS plus b as root. Okay, maybe VS Code is not even that good of a scratch paper because it autocorrects the variable names. Anyways, how do we do this with Vieta's formula? Well, first of all, obviously we know r plus s is equal to negative b over a, and r times s is rs is equal to c over a. Okay, whatever. Now the product of the new roots, the product of these two roots, AR plus B and AS plus B, is going to be, you just multiply the binomial A squared RS plus ARB plus ASB plus B squared. Make sure did not correct anything. And then if we just plug in, because we know RS, and we know this term can be simplified to AB times R plus S, we can simplify this whole long expression down to just AC minus B squared plus B squared. And the last term cancel out, so we get the product of the roots are AC, which means that C over A, which is the product, well, not C over A, but like the constant term over the leading coefficient is going to be AC. So that means the only equation that satisfies that is x squared minus bx plus ac. That's the only one that satisfies the requirement that constant term divided by the leading coefficient is ac. So that has to be our answer. So the answer is B. But this is the little bit boring way because everyone knows Vieta's formula. So there's another more interesting way, I would say, and it's function decompositions. And it's something that I've never been good at. Every time I look at this problem, I don't know how to do this function decomposition way. This is going to be the fourth time I've reviewed this problem. And also, every other function decomposition problem that I've tried, I've also missed. So I think it's a pretty important part that I don't yet know. So I'm going to do the function decomposition as well. So basically, instead of treating this equation still as an equation, we treat it as a function of fx. And that is equal to, obviously, x squared plus bx plus c. Except if I can type correctly. And now, basically what we wish to do is to convert this function f into some kind of function g in which g of ar plus b is 0. And same thing with as plus b. Because right now we know fr is 0, and same thing with fs. So let's think about it. We want some type of transformation before we actually get x into the input that makes this function 0 at ar plus b. So first of all, let's just try plugging in AR plus B into F. So we have F AR plus B, which obviously is not 0. But since we only actually care about what we feed into the final equation, if we do some transformations such as this, notice that AR plus B minus B over A, that's just going to be R. So this thing is still going to be 0. So notice that AR plus B, we can just treat that as its own individual value. We can't call it X. Well, I mean, we can, but I'd rather just call it Y. So F of Y minus B over A is equal to 0. So what G has gy equals 0? It's literally just Y minus, now we can, should I use Y or X? Y minus B over A. If we can plug this in place of X, and plug it into ax squared plus bx plus c, and just do a bunch of calculations, we should get the right answer. And in this case, I don't want to do a bunch of calculations, but after you do that, I believe you have to multiply both sides by a or c or something like that. But after a while, you get the same answer as we got from via this formula, which is x squared minus bx plus ac. Okay, so that was it for this problem. I know I probably should have multiplied it out at the end of the function decomposition solution, but I did not because we don't have enough time. Today is the day before AMC. So if you're just looking for your daily dose of algebra or daily dose of math, whatever you want to call it, that's it for this video. And now it's just going to be me yapping about some AMC mentality and stuff, I guess. So first of all, I'm just going to be talking about how I think a few stuff that will help you prepare your mentality for AMC tomorrow as a coder, as a programmer. Not if you're mathlete, if you main math, get out of here. Y'all are stinky. So basically, for us coders, I feel like one very different thing, other than the fact that this is a 75-minute test rather than a 5-hour test or a 4-hour test like USACO, is the short amount of time you have between 10A and 10B. Like when I'm taking December, my mentality is like pretty relaxed because I know I have 3 other tries ahead of me and I have 3 months till the latest try of this season. So I know that I got this. Even if I only get like a 600, 633, which is indeed what happened last December, I still have 3 more tries and I can improve over the course of 1 to 3 months. But if you think about it, AMC, even though 10A and 10B only has 1 week between them, it's actually almost the same thing because a 5-hour contest for US Open and a 75-minute contest for AMC, that's exactly 4 times. And there's 1 week gap between 10A and 10B, while there's about 4-week gap between every 2 USACO contests, December and then January and February and US Open. So if you multiply that 1 week gap by the 4 times longer length the USACO has, you realize that you can basically mock the exact same number of tests for AMC in between the 10A and 10B as you can for USACO between December and January or January and February. So if you think about it that way, it's not actually that stressful, the 1 week between 10A and 10B, because you basically have the same amount of time as you did between any 2 USACO contests. So there's not that much to stress about on 10A and think that, oh, if I mess up 10A, I don't have enough time to improve and not mess up 10B. You do have enough time. It's basically USACO. If you can mess up December and cook January, then yeah, you can mess up 10A and cook 10B. So that's a little bit of mentality I used. And the second, I think even more important part is about stress. So, well, we're all STEM students and it's a big competition, so we're all going to be stressful. But I think us coders who doesn't main math, stress is going to be towards our favor. Well, not if you're like some very, very ORS coder and very, very ORS mathlete and you're like mocking 120s, 130s every single time. But for someone like me who's mocking like 90, 99, 100, something, 101, something like that, stress is going to be towards our favor because every time I mocked, I'm like usually 2-3 points, 3-4 points below qualification, just like a tiny bit below AME qualification. And that's my performance with no stress. So if without stress, I'm not going to call AME anyways, stress can only help me. Like stress might be detrimental to me and make my score from a 90 to maybe 60, but that's not that much of a difference because 90 and 60 are both not AME equal. But stress could also help you if the adrenaline and some other chemistry in your brain, whatever, just work the right way. You might bring that 90 up a tiny bit, 96, 100, 110, and you just might call AME. So if you think about it that way, it's kind of like something we talked about in English class, which is kind of like philosophy at this point. But following the rules are for people who are already successful. Breaking the rules are the privileges of the losers, which us coders are basically the losers. I'm doing air quotes with my hands, are basically the losers of math because we don't make math. We have a major disadvantage over these smelly, stinky math nerds. So pressure is going to be detrimental or beneficial to both of us, but it's going to be more beneficial to us coders who don't make math than the math nerds. Because they are expecting or very much wanting AME equal and like they're mocking scores that can get them AME equal. While we are just like sitting here with not as much experience in math as they do. So pressure can only help us more than they will help them. So I've been yapping for way too long. Good luck for everyone taking AMC tomorrow. I would say bad luck because if you have good luck and you make AME, then you'll take one spot in the top, 3,000 or 7,000 people who call AME. But you're also watching my videos, so there's usually only like 30 people who does that. So I don't think that will affect anything. So good luck tomorrow.